Today we're looking at Chapter 3, Day 3, and shapes of graphs, but the more important thing that we're going to focus on is the average rate of change. Now, if you look down here, the average rate of change is delta f over delta x, and you might be saying, well, that's just slope, and you would be 100% correct, right? Y2 minus y1 over x2 minus x1. And typically, we're just looking at slope. And if it was a linear equation, well, then you just plug in like you did back in algebra class, right? Well, today we're going to look at, well, what if it's not just linear? What if you have some type of curve and we want to find the average rate of change from A to B, right? So we want to find the average rate of change from A to B. So what we can do is we can actually, with that curve, is we can go in where A is, and we can find its corresponding y value, right? This would just be f of A. If I go up from the B, I have that corresponding y value, right about there, we'll say. And we know that that's f of B. And so what I can do then is I can just draw a line that connects those two coordinates, and then I can find the slope of that line. And then that will be my average rate of change for a curve. All right, so it's very similar to what you did in algebra class, finding the slope equation, just that I got to just find the coordinates on there. Okay, and so if you look at some of the equations, here is one example of using a difference quotient used to find the average rate of change. F of x minus f of a over x minus a. Now f of x represents, let's say you didn't know what the ending point was, right? Let's say we didn't know this, and it was x, so then you can use that equation that you had there. Sometimes they're going to use this other one, all right, this other equation. We'll use this a lot because, you know, being this is pre-calculus, you're getting ready for calculus next year. A lot of you see this over and over again. And that h, what that h represents, the h is the difference between those two x values. And that's why we say the second coordinate, the second x value, is f of x plus h. That's the difference between them, whereas f of x is where you're starting from. Now, this h that's down here, somebody's saying, well, where'd that h come from? Well, if we look at it, if the second x value was x plus h, and the first x value was x, well, what they did is that equation just comes from simplifying that denominator, right? And you would be left with just an h right there. So it's just a shorter way of writing it, okay? But like I said, I have there in green. That's typically what we're going to use when we're doing difference quotients, especially if we have a lot of variables, all right? So let's try it out. So it's asking me to find the difference quotients for f of x equals x squared minus 2x plus 4, a nice little quadratic that we see here. And what I'm going to do is simply just use this equation. Well, in order to use it, I need to know I have f of x, I have h, that's just a variable. I need to know what f of x plus h is. So if you remember back to day one, what we did was that just told me notation-wise just to replace all the x's with x plus h. So if I do that, I'm going to have x plus h squared minus 2 times x plus h plus 4. What you may want to do right here is you may want to simplify that. So you have a binomial that's squared, so please be careful. If you got to write it twice and multiply it out, that's fine. Otherwise, some of you can jump right to, all right, that's x squared plus 2xh plus h squared. If I distribute the negative 2 here, I have minus 2x minus 2h, and then I got the plus 4. So that whole thing is f of x plus h. All right, so now if I go here and I'm going to use this to find my difference quotient abbreviation right here. Okay, it says f of x plus h. That's my starting point. Well, the nice thing is I found that already, right? Right there. All right, so we have x squared plus 2xh plus h squared minus 2x minus 2h plus 4 minus, well, the second part of the equation says f of x. Well, that's the nice thing given to us already, right? So, but you have to make sure you do the quantity x squared minus 2x plus 4, because you're subtracting the entire group Okay, so in order to find the difference quotient, we take the first part minus the second part, and that whole thing is going to be divided by h. All right, so the trickiest part is going ahead and writing the information in there. If you have this memorized or have it handily ready for you, it should be pretty quick and easy. Just be careful to avoid silly algebra mistakes. All right, the next part that people make mistakes on. If you have this subtraction here, please be careful that you distribute carefully. So you say, okay, I have x squared plus 2xh plus h squared minus 2x minus 2h plus 4, and I'm going to subtract x squared. That now becomes a plus 2xh plus 4, and that whole thing is going to be divided by h. Now, some of you saying, well, do I need to actually write out this step right here where I distribute the negative? You don't have to, but you must avoid silly mistakes. All right. So if you're going to make a silly mistake, write it again, get 100%, be awesome. All right, here we go. Let's combine some stuff. So let's get rid of these x squareds. Let's get rid of this minus 2x and this plus 2x. Let's get rid of this 4 and see, Mr. A made a silly mistake. See? Oh, gotta be careful. Hopefully you caught that, right? I was just testing you, make sure you're paying attention. All right, so plus 4 minus 4. There we go. Okay, so now if I clear the dust a little bit and say, hey, what's left? 2xh plus h squared minus 2h. That's all still divided by h. Now you can simplify this two ways. One way is just to take that h and share it with all three pieces on top. The other way you may have learned is all three parts have an h in common. So if we factor that out, you take out the h, I have 2x. That's h to the first now, minus 2. This h is still hanging out in the bottom. Oh, look, that's nice. They get rid of each other. And so now I know that 2x plus h minus 2 is the basic equation that I can use if I knew what the x coordinate is, if I knew what the space between a and b is, I could plug those values in there and I could find the difference quotient at a certain point for our x squared minus 2x plus 4. Okay, so that's how you can use it. They have variables. All right. Now, the next part is, well, what happens if the nice thing is they give you average rate of change and they give you coordinates? And the thing to recognize for this is that this right here is x1 and x2. That's not an xy coordinate. Okay, so make sure you're careful with that. So you find the average rate of change. If you're given two x values, what I would do is find their corresponding y values. So I can go through and I can find g of -1, right? If I plug that in there, okay? And we talked before about if you have the equation and you have written great algebra or function notation, then you can go through and just plug in -1. And if you plug in -1 carefully in there, right, you should get a +6. If you're not sure, show the work of plugging that in. So what does that mean? Well, that just means one of the points we're talking about is -1, 6. Now, the second thing we need is we need g of 3. Again, you have the equation, you're showing great function notation. If you plug in the 3 right here, you should also get a 6, right? So hopefully there you're being careful. So that just means now that we have the coordinate 3 comma 6. And so now when I find the average rate of change, right? The average rate of change, well, I can just go through and do the equation I had at the top, right? Do my slope, just my y2 minus y1 over x2 minus x1, right? You've done that probably a million times in algebra class. So I'm going to say, all right, I'll let this be my y2 and my x2. So I'm going to say 6 minus 6 over 3. Now be careful. It's minus a -1, so I'm going to make it a +1, right? Overall, you get 0. So what does that mean? Which means the average rate of change on that particular graph would be 0. Well, hopefully you remember that things are kicking in from algebra. You're like, oh, that just means that I have a horizontal line. Which, yeah, if you think about what this graph looks like, at -1, it was 6. It gets 0, 0. If I were to plug in 1 there, I got -2. If I plug in 2, I get back to 0. And then we said 3 was 6. So here was, draw nicely, hopefully a little better than I did. And so if we look at that, well, all it's saying is, yeah, the average rate of change between those values would have a slope of 0, right? You don't need to draw that, but you can actually see it and visualize what's going on there. And oh yeah, that just makes sense, right? It's a horizontal line if I connect those 2 points, okay? And that just proved it right there for us, all right? So that's just an easy way to find the average rate of change. And the biggest thing to realize is you're given 2 x's here in that notation, not an x and a y, okay? So please be careful with that. All right, let's go take a look at the backside here. Now we're going to start this off with a U try. So if you want to try this one on your own, all right, go ahead and pause it here and then come back and check your answer. I like it. All right, try that a little bit there to see how you're doing first and come back and check. That's always a good one. All right, so pause for a minute here. Okay, so hopefully you had a chance to try that. If you didn't, let's dig in together then. All right, so now the thing that's tricky about this is given that this is a function, we got to find the b value such that the average, so the nice thing is they're giving us the average rate of change is 1/7. So they kind of switched around for us. So if you look at what we were given here, is we're given the x1 and the x2. So let's use our equation that we had from the beginning, right? So we know, actually, let's do this. We can say that f of 1, right, because I got to find the corresponding y coordinate. If I plug in 1 into my equation there, square root of 1, that's easily just 1. So I know that one coordinate is 1, 1. The other coordinates that I have there, the other ordered pair, I should say, we would say, well, let's just plug in b, right? Because it's telling us if x2 is b, let's find out its corresponding y value. So if I plug it in there, I get the square root of b. So that just means my other coordinate is b, square root of b. All right. So using the average rate of change, well, that just tells us to take y2 minus y1 over x2 minus x1. Well, here typically we didn't know what it was, but in this case they told us it's 1/7. So let's just plug it in the equation, right? So all I'm doing is taking all this and I'm just plugging it in there. All right. So now I just have to do is just do some algebra to solve this. Everyone's favorite, cross multiply. So if I were to make sure you do the entire quantity times 7, the entire quantity times 1. So if I do that, I'm going to put it down here a little bit, and I'm going to say, okay, that means that I'm going to, I'm going to come right over here. There we go. All right. So if I take 7 times the quantity, right, make sure you distribute, square root of b still on the inside, minus 7. Distribute the 1, I'm going to have b minus 1. All right, so I got this. Let's clean this up a little bit. Yeah, that looks kind of bad. Let's fix that a little bit. That's a little better. All right, so if I add the 7 over, I have 7 times the square root of b. Okay, square root of b is equal to b. If I add 7, please be careful with the algebra right there. I got a plus 6. All right, so now how to get rid of that square root? Well, hopefully you said, well, let's go through and square both sides. I like what you're thinking. I like what you're thinking. Square there, square there. All right, so if I do that, okay, I'm going to have 49b. Please be careful. Make sure you multiply this out because the quantity squared, we talked about that earlier on the previous page. So I have b squared plus 12b plus 36, right? So now I want to make this equal to 0 because I got a quadratic. Now we're really testing your algebra skills right here. Okay, so I'm running out of room right here, so I'm going to move it up here. I'm going to say, okay, I got 0 equals b squared. If I subtract 49b, you're going to have negative 37b plus 36. Now I got to go through and I want to factor this. Don't need to use a quad. Put that away. Hopefully you say, well, what multiplies to 36 as negative 37? You got b minus 1, b minus 36. Probably took you more time if you went through and did that silly a quad. Use it when we need it, not right now. So I got b equals 1 and 36, which makes sense if you think about it because the 1 was what we started with, right? We started with a 1 over there. So that makes sense that 1's there. So obviously the b that we're looking for is 36. Okay. So what I want to do is it asks us to find the b value such that the average rate of change. So we got that. B is 36. What I always like to do, and I know you guys all love to do as well, is I'm going to go through and I just want to check my answer. So I'll go over here and say, okay, if I want to check, I know you guys always do that, right? Always double check your answer. So if I plug that back in there, I would say, is the square root of 36 minus 1 over 36 minus 1? Well, if I look at the square root of 36, that's just 6. 6 minus 1, well, that's 5. 36 minus 1, that's 35. And if I do some great simplification, I got 1/7. And so I know that, hey, everything worked out fantastic. All right, so that's just a way to check. So yeah, they just changed us up a little bit. Now instead of giving the coordinates, they actually gave you the final answer and you had to work back and get one of the coordinates right there. So hopefully you did okay when you paused it and checked your answer. Hopefully you got B equals 36. All right. Now we're going to get some try to find part in here. First part of this should be pretty easy, right? If you want to pause it right here and try some of these on your own, go ahead. If we look at here, the domain, if we were to count each spot as 1, we can see that the farthest left the domain goes, it starts at -2, and it's with a bracket because you got a closed part, and 1, 2, 3, all the way to 4. All right, the range we know is -1, and it goes up to +1. Remember the range, start at your lowest point, work your way up until you get to the highest point. Okay? All right, so there's our domain and range. That should be reviewed. We've done that for a couple days now. Now, max and min values. When they ask you for the values, the biggest thing is they're asking for the Y information. Okay, so some students make a mistake and they'll give you the X and it's wrong right away. You're asking for the values, so they're asking you what is the Y value where it's the maximum. Obviously, maximum means the greatest height. The greatest height we can see occurs here at 1. So we would say that the maximum value is 1. The minimum value, right? We're looking for the lowest number. We can see it occurs actually twice right there and there. You only need to say what's the value. We don't have to write it twice. Just got to say the minimum value is -1. Okay, so we got a max value, min value, looking at the Y values. If it asked where, then you could say the X coordinates. Okay, then you use the X values. So make sure you see the difference there. All right, the intervals where f of X increases. Now, these two, now we're talking about the X's. Okay, so these two use the Y, these two use the X. All right, so if we do that, well, I want to look where f of X increases. So what I'm going to do is I'm going to say, well, actually, we use a different color here, see it a little better. All right, so if I go here, I see it's going down, down, down. Well, this is where it hits the minimum, and then it starts to go back up, right? It's increasing. So I say, well, the X is where that occurs at. Starts off at -1 and it's increasing until it gets here at 1. So I know from -1 to 1, and I usually just put parentheses on that. College Board has said you can use parentheses for that, so I'm going to use the same thing. So I know from -1 to 1, the graph is increasing, and then I also know from 3 to 4. So I'm going to put a little union, 3 to 4. So those are the X values where it is increasing. Okay, so if we want to look at where it's decreasing, obviously that's the different parts. So it starts decreasing at -2, works its way down until it gets to -1, and then it was increasing. We're going to skip that part for the part E, and then from 1 to 3 is the next interval where it is decreasing. Okay, so when asked for the maximum minimum values in parts B and C, that's the Y coordinates. When asked you for the intervals where it's increasing or decreasing, like in D and E, that's the X coordinate. Okay, now last part, when does f of X equal 0? All right, so f of X equals 0, we can see it right here. We can say this happens at X equals -2. Again, right here at X equals 0. Again, there and there. So we know that at 2 and at 4. All right. So hopefully some of that was review. Maybe a couple of new things there with B through E, but overall should be pretty straightforward. Just be careful reading. Make sure you see B and C use the Y value, D and E use the X values. All right, last one. Here's a good review. If you want to pause it right here to see how you're doing on your piecewise graphing, go ahead and pause it and then come back. All right, so if I were to go through and look at this, remember, this is a function that's made up into multiple parts. That's why it's called a piecewise function. Together, they form the overall function that we have there. So this condition if x is less than or equal to 0, so again, you may just recognize, oh, I'm just going to use that equation. That's a nice linear equation. Or if it helps, what you can do is make a table. So we have x, we have f of x. Pick some numbers that are less than or equal to 0, so like -2, -1, and 0. So I say, well, if I plug in -2, well, that's easy. That's just 1. That's just 2. That's just 3. And since it's equal to, I'm going to put a closed dot on there. So I'm going to say, okay, well, -2 was 1, -1 was 2, and 0 was 3, right? Which is basically the same thing as if you go a couple more this way. And we're taking all these. There we go. All right, so which is basically what you would have gotten if you just had recognized, okay, y-intercept of 3, slope of 1, all right, but I'm going to stop at x is less than or equal to 0, right? That's my stopping point, okay? So the next part just says, well, if x is greater than 0, okay, if x is greater than 0, so what are some values? Again, I'm going to start at 0. Because I want to make sure if I start at 1, I'm missing all the decimals like 0.1, 0.3, 0.7. I got to include those. So if I know that I'm starting at 0, well, the nice thing is there's no x value. It's telling me that my function is always -5. There we go. And it was always -5. So what I can know is that's just going to be a horizontal line, right? So I say, okay, I got here. I'll get this out of the way. There we go. Some on my screen. Okay, there we go. So I get 0, -5. Now, that is an open circle. So if x is greater than or equal to 0, that means we're not including it. All right, so I got 1, -5, 2, -5. Oh, you recognize that's just a horizontal line, right? Y equals -5 is just a horizontal line going on forever to the right. Okay, and so there again is my piecewise graph. It's made up of two pieces. Together they form one entire function. My domain would be all reals, right? If I had to go from -infinity to infinity, you could go ahead and answer those types of questions, right? So there is day 3. If you got questions, please ask your teacher, and good luck.